Hello, dear students. Today we have Proposition 24 of Book 3. Proposition 24 of Book 3. Similar segments of circles on equal straight lines are equal to one another. Given, similar. Given, equality. To prove that this is equal to this. Okay? So we're going to do that by putting the green one on the black one, just like we did with triangles in Book 1, I think Proposition 4. Okay? So let this be, let's put the green, let's put the green one on the black one. We're going to do it like this. We're going to put this point on that point. So then we're going to line up this line with this line. Perfectly lined up. And then we're going to show, right, first thing, that this point will be perfectly lined up with that point. If not, it'll go further or short. If it's further, then it's greater than it, because the whole is greater than the part. So it's both unequal to it, but it's given that it's equal to it. So it's both unequal and equal. Problem. So blah, 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 it necessarily falls on it. Doesn't fall short, doesn't fall long, falls right on it. Great. Now, this green semicircle will either fall right on top of this, entirely outside of it, or entirely within it. This was cut after cutting, but this part, the segment. Great. Or it'll fall askew. If it falls entirely without, then you've got this problem over here. Remember the previous Proposition 23? That showed that there cannot be constructed on the same straight line two similar circles that are segments of circles that are unequal to each other. Remember, we proved that? Okay? So, we know that this is greater than this because the whole is greater than the part. But if it's greater, it's unequal. But we know that we cannot construct on the same straight line two similar segments of circle that are both equal to each other. That are unequal. So here this is unequal because it's the whole. Here, but it cannot be unequal because we showed in previous prop that you cannot put on the same straight line two similar segments of circles that are unequal to each other. Okay, because you get this problem. Okay. So same thing we would have here if it fell entirely within. If it falls within, we've got two similar segments of circles constructed on the same straight line that are unequal. How do we know they're unequal? Because the whole is greater than the part. These two things are necessarily unequal. Okay, well, Mr. Smarty Pants has one more trick up his sleeve, and that's this one. What if it fell askew? And now you can't use the whole is greater than the part. What if it fell askew like that? It's not the whole being greater than the part. What do? Oh, no problem. Because here we have uno, dos, tres, one circle cutting another circle at more points than two. You remember that? And the proposition the drawing looks something like this. And you connected things up and you showed that they would share the same center, right? And you say, but you can't have two circles which cut one another share the same center. You proved that as well with reductio. So we got this proof depending on this proof, and this proof depending on two circles that cut one another and can't share the same center. Okay? But in any case, cool here. We showed that if the whole is greater than the part, it's a problem. Both this way and this way. We showed now if it falls askew, we have a problem because this circle, this segment of this circle would cut the other segment, and then you make the whole circles, at more points than two. Uno, dos, tres. 3 points it's cutting it. That's impossible. So therefore, if it can't fall, if putting this on this, it can't fall entirely outside of it and entirely inside of it, and it can't fall askew, guess where it falls? Perfectly on the red line, on the circumference. And we know then that things which coincide are equal. Figures which coincide are equal. So this would be perfectly coinciding with this, therefore it would be equal to it, and it is equal to it. Therefore we have shown that two similar segments of circles on equal bases will be equal to each other. Similar and equal. A circle can be similar to another circle and not be equal to it. Okay? But it can also have a circle similar to another circle and be perfectly equal. We know that in segments now, If the segments are similar and they're on equal bases, those segments are also equal. Thank you. Bye-bye.